Hi everyone. So till now in this chapter we were studying about rectangular waveguide. So in that we have seen the wave equations. Then we saw about the waveguide parameters, like we found the value of beta g, neta, all those values we found. Then we saw the power calculation in the last lecture. In the last lecture only we saw the power calculation as well. So I told you only one question has been asked till this date in GATE examination. Only one question has been asked from this particular topic. And then in the last I told you that we are going to see the field visualization, field patterns we need to see. So how the field looks like inside a waveguide, that we need to see. So from this topic as well, till now, till this date, only one question has been asked. But certainly more questions can come. It is not that important, but certainly we need to study. Only it is roughly around, it will take you only 5 minutes to understand this particular topic. So field visualization we need to study. So let's understand the field visualization of TE10 mode. So first we are understanding the visualization of TE10 mode. What is our TE10 mode? It is a dominant mode, right? So in TE10 mode, what will be your EXS? This we have already seen in the last lecture. So EXS is a function of cos x sin y. So there will be some magnitude, then cos m pi by a into x and sin n pi by b into y. But what is the value of n? N is 0. So if you put 0 here, what will happen? Sin 0 will be 0 only. So EXS is 0. Certainly your HYS will also be 0. And since it is transferred the electric mode, so EZS will also be 0. So in electric field, EXS is 0, EZS is 0. What will remain? Only EYS will remain. And the value of M is 1. And what will be what is EYS? EYS is a function of sin x cos y. So sin m pi by a into x, but the value of M is 1. And the value of N is 0. So if you put 0 here, what will happen? 0 into anything will be 0, cos 0 is 1. So this term will be gone. And m equals to 1 has been put here, so this will be sinusoid term only. Same thing will happen here. This term will be gone because cos 0 is 1 and this will be there as it is. So here EYS and HXS would be existing. Along with that, HZS will also be there. Why is that so? Because it is transverse electric mode. That means magnetic field in the direction of propagation will be present. So HZS will also be there, but this is cos 0, that would be 1. And M value will be 1. So these are the field present. So in case of electric field, what all components you can see? E01. In case of electric field, I can only see EYS component, EYS AY cap. I cannot see X component because EXS is 0 and EZS is also 0. So only in electric field, only one component I am having, that is EYS. This we are talking about dominant mode, because only one field visualization we are going to do. So E01 sin pi by a x AY cap. What do you understand by this? And certainly one more thing I forgot here again, that is direction of propagation I forgot to show. So this will be the direction of propagation. And certainly we are writing the phasor form, not the time domain form. So here also direction of propagation should be shown, right? And AY cap. So what do you understand by this? The field is dancing in y direction. The field is dancing in y direction and propagating in z direction, having component of function of x. Look, what does this represent? This represents the standing wave pattern, right? Sin pi by a into x represents the standing wave pattern that you know. And the value of M is 1. M is 1 means number of half cycle in x direction will be 1. Number of half cycle in x direction will be 1. And number of half cycle in y direction, what that would be? That would be shown by n. So value of n is 0. Here value of M is 1 and n is 0. That means number of half cycle in x direction would be 1 and the number of half cycle in y direction would be 0. Now if I take that time domain form, let's just say I need to calculate E omega t or t, you can say ET if I need to take. So what I need to do, e to the power j omega t I will add here, and now this gamma g will be changed by j beta g into z. And when I take the real part, what I will get? E01 sin pi by a into x and cos omega t minus beta g z. This we used to do in our EM wave, right? From phasor, if I need to go to the time domain form or time harmonic vector field form, what I need to do? I need to add e to the power j omega t. Then what will happen? I will take the real part. If I take the real part, then cos function we will get, and this function is already there. So this represents the standing wave pattern. So now what do you understand? You are having a standing wave pattern on x-axis, dancing in y direction, and propagation is along the z. So let me make it, okay? So let me show it to you. Let's just say I make only the cross section. Look, this is not your waveguide. This is your x direction. This is your y direction. Here z direction is also there. Z direction is also there. So this is my waveguide actually. But I am only making the cross section. So this is my complete waveguide. That from here wave will get into it, and in x direction it will make standing wave pattern. In y direction it will make standing wave pattern, and the field and the wave will propagate in z direction. So this is my complete waveguide, but I am only making the cross section. Cross section means only this initial part I am making. And if I talk about electric field, what was this? This was x equals to y equals to 0. This was your x equals to a, and this was your y equals to b, right? Now if x value is 0, so at that time your complete field is 0, and when x value is a, at that time also your complete field is 0. Now what does this represent? Let's just say x value is a by 2. When x value is a by 2, what is your field? E naught a by 2, pi by a into a by 2. So sin pi by 2, what is the value of sin pi by 2? 1. So you are having the component in y direction. The component in y direction, field is dancing in y direction. If you remember our EM wave, what we used to write? E naught cos omega t minus beta z ax cap. What I used to say? The field is propagating in z direction, but it is dancing in x direction. That means if this is your z and this is your x, so your field will be something like this, and it will be propagating in z direction. If you remember the animation, the field was dancing like this and it was propagating in z direction. The same thing is happening here. The field will dance along y because components will be along y. Vector component will be along y. Here you are having the component of E naught 1 ay cap. If I only talk about the magnitude, this is the phase. So forget about the phase. If I only talk about the magnitude, so E naught 1 ay cap, the vector es at x equals to a by 2. Vector es at x equals to a by 2. If you put a by 2 here, what you will get? Sin pi by 2. Sin pi by 2 is 1. So E naught 1 ay cap, and that will be the maximum amplitude, right? So in y direction you are having E naught 1 amplitude, and then this will be completely sinusoid. Basic thing is this will be sinusoid only. Look, there will be infinite vectors like this. There would be infinite vectors. This vector, another vector would be there. In between there will be another vector. Here also there will be another vector. But we are not making all the vectors. The thing is, you will have one half cycle on x-axis, because the value of m is 1 and value of n is 0. So here there is no half cycle. On x-axis you are having one half cycle. This is the electric field pattern. Are you getting this point? And from this expression also you can verify it. If you put x equals to 0, that means 0 value. If you put x equals to a, that means 0 value. And in between you will get the maximum value at a by 2. Right? And this is the length you are having. You are having a length of a only. So another half cycle will not be there. So inside the waveguide you will get one half cycle. Inside the waveguide you will get one half cycle of electric field. Or you can say one half cycle of standing wave pattern along x. Standing wave pattern along x dancing in y direction. Is that clear to you? So this is the electric field pattern we have made. This is the electric field pattern we have made. If we talk about magnetic field pattern. So in magnetic field, what all components you can see? Two components are there. So let me write down the magnetic field. H of s I need to write down. So some magnitude H naught 1 will be there. Sin pi by ax e to the power minus gamma gz, and it is in x direction, plus this is in z direction. H naught cos pi by a x e to the power minus gamma g z. This is in z direction. Can you let me know how will the resultant look like? How will the resultant of these two fields look like? Two fields which are orthogonal, having a phase difference of pi by 2. How does it look like? If you remember the wave polarization lecture, two fields which are perpendicular to each other, one is in x direction, one is in z direction, having a phase difference of pi by 2. What will be the resultant? If the magnitude is same, then the resultant will be elliptical, and if the magnitude is different, then the resultant will be circular, right? So resultant of this field will be circular in which plane? In xz plane. The resultant of this will be circular in xz plane, which will be propagating in z direction. Look, it is very tough to visualize it, but I am giving you best possible visualization which you can get from this particular topic, field visualization of waveguide. So we are only seeing dominant mode. Let's just say if the mode is TE32, then how tough it will be. This is TE10. Here the fields are very less, but in TE32 a lot of fields can exist. It might happen that EXX is there. Not, it might not happen. It will happen that EXX will also be there, EYS will also be there, and EZS cannot be there since it is TE. Then HXX will also be there, HYS will also be there, HZS will also be there. Then what will be the combination of that? How does the field look like? So that will be very tough to visualize, right? But we are visualizing TE10. So in TE10, in electric field we are having only one component, that is EYS. So that we can draw. How did we draw it? That it is a standing wave along x, dancing in y direction. Standing wave along x, dancing in y direction. So along x you can see number of half cycle are 1, and along y there is no half cycle. Like there is no field like this. There is no field like this. If there was field like this, then you would have said that there is half cycles along y direction as well. But there is no half cycle along y direction. There is only half cycle along x direction, right? And this circle should have been made much clearer because it should pass from all the peak. It is sinusoid. You just consider that it is sinusoid. But I am not able to make a perfect diagram. So this is how the field would look like. Now if I talk about the magnetic field, then magnetic field are having two components which are orthogonal to each other, having a phase difference of pi by 2, right? So it will be elliptical because here you can see that magnitude are different. So it will be elliptical, right? So total component, electric field as well and magnetic field as well, this is how it will look like. This is your electric field and this is your magnetic field. So this is my magnetic field and this is your electric field. So what will happen? This is a standing wave, this is a standing wave which will be propagating in z direction. This standing wave will be propagating in z direction. By which function it will be propagating? Cos omega t minus beta z. So with respect to time, you will see that it is propagating in positive z direction, cos omega t minus beta z. Although here we have written only the phasor form. If I need to write down the time domain form, then e to the power j omega t I will multiply and then I will take the real part. So this is how it will propagate, that at z equals to 0 you are having maximum amplitude. If you put z equals to 0 here, you are having maximum amplitude. With respect to time, it will keep on moving. So can you let me know which is this axis? This is your z axis, right? This is your z axis. Can you let me know how much this distance will be? Here you are having peak and at this distance you are having negative peak. Graph of cos. Peak, negative peak. How much will be this distance? Lambda by 2. Because peaks are repeated after every lambda by 2 distance. If it was a standing wave pattern, then what you would have taken? You would have taken the magnitude. Basically, this is the standing wave pattern. Are you getting this point? This is the standing wave pattern. Now, this standing wave pattern is being propagated. This standing wave pattern is being propagated. So it will propagate in this manner, that here you are having maximum amplitude, then next this amplitude will be less, then next this amplitude will be more less, and then slowly it will become 0, and then it will become negative. So here it is becoming negative. So how much this distance will be? Lambda by 2, because a complete cycle is lambda. A complete cycle is lambda, but this distance will be lambda by 2, half cycle. So this distance will be lambda by 2, right? And this is how the magnetic fields will look like: circular, circular, circular. So no one will ask you this in your examination. Let me tell you, no one will ask you this thing in your examination. Certainly, this visualization no one will ask you. But did you get a basic idea that how the fields will look like inside a waveguide? So that's why we never study this topic, because it is very tough to visualize. But I hope I have given a good enough visualization to you. So in the examination, what will be given? In the examination, what they will do is that they will only make this box. They will only make this box. What they will show you, that they will make this box like this. And they will say that they will say that this is along x and this is along y. This is what they will say. Then what you will do? First thing is that they will say that this is the electric field pattern. They will say that this is electric field pattern. This will be written in the question. Okay. In the question it will be written that this is the electric field pattern. So what you will do? First you will analyze that it is TE mode. How will you analyze whether it is TE or TM? That I will tell you in this lecture only. So first you will analyze that it is a TE mode. How will you analyze whether it is TE or TM? That I will tell you in this lecture only. So do not worry about that. So as of now you consider that it is a TE mode. Now whether it will be, what will be the value of Mn? That you need to tell now. So what is M? M is associated with X. So M is the number of half cycle in X direction. And what is N? N is associated with Y. N is the number of half cycle in Y direction. So number of half cycle in X direction, how much do you see? I should not say X direction, number of half cycle on X axis. What I need to say? M is the number of half cycle on X axis. So on X axis, how many half cycles you can see? 1. So M value is 1. And on Y axis, how many half cycles you can see? No half cycle I can see. On Y axis, there is no half cycle, no. On Y axis, there are no half cycles. So on Y axis, I can see 0 half cycle. So this field is TE10. So this is how you will answer in the examination. Just a second. Okay, so you understood it, right? So let me erase this one. Yeah. So this is how you will be answering in the examination. So certainly they will make electric field pattern. So what different kind of questions they can ask? Let's see that. So now we are going to see identify TE mode pattern. How it is TE mode? That later on I will tell you when I teach you TM mode pattern. So as of now you consider that you know it is TE. Now you need to tell the M and N values. So what you will see? That number of half cycles. Because they will make the fields. They will not give you this is sinusoid curve. They will make the fields. They will make the arrow. So they will make the arrow like this. Then what do you see? On X direction I can see 1 half cycle. But on Y direction I cannot see any half cycle. So it is TE10. Now the other way to represent this is this way. What is that? Here you are having maximum amplitude. No? Right in the middle you are having maximum amplitude. Like there will be more field patterns like this. There will be more field patterns like this. So in between you are having the maximum amplitude. So where you are having maximum amplitude, they will make the vectors close. Here we are having maximum amplitude, so they have made the vector close. Here you are having less amplitude. In here you are having less amplitudes, no? So they have made the vector far away. So this is like sinusoid only. Like this is like 1 half cycle only. Are you able to understand? In between there is maximum amplitude. That's why they have made the vector close. Otherwise they will make the vector far. So this is like a sinusoid only. This is like 1 half cycle only. So this is your TE10 only. Because in X direction I can see 1 half cycle and in Y direction I can see 0 half cycle. What about this one? In between they have made closer and here they have made far away. That means here less amplitude is there. When you get here, you get the maximum amplitude and then amplitude is decreased. So what do you see here? As of now you know that it is TE. Now you need to tell M and N values. So how many half cycles you see in X direction? No half cycle is there in X direction. So M value is 0. What about the N value? Number of half cycle in y direction, that is 1. That's it. Okay. So this is T01. So this is how you need to analyze. Let's see this question. Number of half cycle in x direction. So this is a half cycle and this is a half cycle. Is this the complete half cycle? This is half of half cycle. Are you able to understand what I am saying? This is one half cycle. This is your one half cycle. What about this? This is your half cycle. Half cycle. So this is half cycle and this is half cycle. So one half cycle you are getting in x direction. Let's just say I already know that it is TE mode. How I will differentiate between TE and TM, that I will tell you. So I already know that it is TE mode, and they will say that this is the electric field lines. This is the electric field lines. They will already say that these are the electric field lines. So they will say these are electric field lines. Now I know that it is my TE mode. Okay. If it is my TE mode, can I see the half cycles on x direction? There is one half cycle on x direction. How many half cycles are there on y direction? Half cycle and half cycle. That is 1, 2 and 3. There are 3 half cycles in y direction. This will also be given that this is x, this is y. But from now onwards, by default, you will take this as x and this as y. This you will take by default. But in the examination, it will be shown that this is x, this is y. So in x direction, you see one half cycle, because this is half cycle, this is half cycle. So half and half is becoming one half cycle. So you are getting one half cycle in x direction, and you are getting 1, 2 and 3 half cycle in y direction. So TE13. How it is TE mode, that I will tell you. No need to worry. What about here? I can show it as well. In this manner I can show it as well. What about this one? Here you can see one half cycle and half cycle. So let's just say I already know it is TE. So how many half cycle I can see in x direction? 1 and 2. And how many half cycle I can see in y direction? 1, 2 and 3. TE 2, 3. What about this one? How many half cycle I can see in x direction? 1, 2, 3, 4 and 5. What about y? Half is becoming 1 and 2. TE52. What about this one? They will make this arrow that this is going upward, this is going downward, this is going upward. That means what happened was, one pattern was like this. One pattern was like this. Then it is going downward. Then another half cycle has come. Then another half cycle has come. So 3 half cycles have come. One half cycle, one arrow going upward, then arrow going downward, then arrow going upward. So 1 half cycle, 2 half cycle and 3 half cycle. And all these half cycles are made on x axis. So 3 half cycle on x axis and 0 half cycle on y axis. What about this one? 1 half cycle, 2 half cycle, 3 half cycle and 4 half cycle. T4 half cycle in x direction, but in y direction there is 0. What about this one? 1, 2, 3. You can see 3 half cycle, but all are in y direction. In x direction there are 0 half cycle. So 0, 3. 1 half cycle, 2 half cycle and 3 half cycle. So this is how TE03. Are you able to understand what you need to do? They will give the field pattern. They will say that it is electric field. What you need to do? You need to see the x direction and y direction. Then you need to check the number of half cycles. So here number of half cycle was 1 in x direction. So TE1, and in number of half cycle in y direction was 3. 1 half cycle, 2 half cycle, and this is half cycle. So there will be 3 half cycles. Here 1, 2. So TE2, 1, 2, 3. TE2, 3. Here 1, 2, 3, 4, 5, and here there is 2. TE52. Here 1, 2 and 3. So TE30. Here 1, 2, 3, 4. TE40. And here 1, 2, 3. TE03. That's it. That's it about TE fields. Sorry, TE mode. So this is about TE mode, and here you can directly see there is one half cycle, and here also there is one half cycle. So it is TE01. This is TE10. So this kind of questions can be asked in the examination. They will give a particular field pattern and they will ask you which field pattern is what. That's it. Okay. Yeah, so let's start studying about TM mode patterns now. So in between there was an interruption because I was having the cough. So really sorry for that. Now we will start studying about TM mode patterns. So TE mode patterns we already saw. Now first we will see how to differentiate between TE and TM. So in TE mode patterns, you can directly see the number of half cycles. No, here on y axis I can see number of half cycle 1, 2 and 3 half cycles, and on x axis I can see 1 half cycle. Similarly here as well I can see on x axis I can see half cycles. Here also I can see half cycles, but in TM mode pattern you cannot see half cycles. Can you tell me that, sir, this is 1 half cycle? No, this is not half cycle. Half cycle has to be something like this. It is not there. So on x axis, neither on x axis, neither on y axis. This is my x axis and this is my y axis. Neither on x axis I can see any half cycle, neither on y axis I can see any half cycle. So certainly this is TM mode. Here can you see any half cycle? No, TM mode. Here can you see any half cycle? No, TM mode. Here can you see any half cycle? No, TM mode. Now let's get back here. Here in this one, in TE mode, here I said that these are your electric field lines. These are your electric field lines. So yeah, certainly these are your electric field lines, but here there are magnetic field lines as well. What all are those magnetic field lines? These dashed line. These dashed line you can see. These dashed line are your magnetic field line. So this solid line is your E field line, and these dashed line are your H field line. In the examination, certainly they will give the E field line. That's for sure. They will never ignore the E field line. Certainly, that's for sure. If they are asking question on TE mode, they will certainly give E field line. They can ignore the H field line, but they will never ignore the E field line. It might happen that they will not make these dashed line, but 100% they will make the E field lines. So here also, here you can also see some dashed line. So these are your H field line. Here also you can see some dashed line. Here also you can see some dashed line. So these are your H field line. But 100% sure, I am pretty sure that they will give E field line for sure. Here also you can see H field line. So they can ignore H field line but not E field lines. Now in this one, these are your E field lines and these are your H field line. Now in this one, it might happen that they can give, like here also solid line is your E field and dashed line is your H field. So in this one, it can happen that they will give only E field line. Here you can directly see, sorry, they can give only H field line. In this one, if they are asking question from TM, then it might happen that they only give the H field line. You can directly see here, these H field lines are clearly visible. They are framing a circle, right? They are framing a circle. Here also they are framing a circle like this. Here also you can see they are framing a circle. Here also circle. Here also circle. So it might happen that they can give you H field line only. But here certainly they will give you E field line. That's for sure. 100% guarantee is there that if they are asking the field pattern, then they will give you E field line for sure. Here also it might happen that they can only give you E field lines. Here also they can give you only E field line. So what I mean to say is that ideally they should give both of the lines. They should give the E field line as well, H field line as well. Okay. But once when the question came, they only gave the E field line. In that question, it was written that E field lines are shown. So 100% if they are asking question on TE mode, E field line will certainly be there. But if they ask question on H field, sorry, if they ask question on TM mode, then it might happen that they can only give you E field or only give you H field. This kind of questions they did not ask yet, but any day it can come in your examination. So now you know that it is TM, TM, TM. Now you need to tell the MN value. So how will you tell? So what you will do is that here what you can see, circles. Here I can see circles. These circles, these dots I can see. Those empty spaces I can see. These empty spaces I can see. So I will draw a line. Really sorry, I need to pause. Yeah, so what I was saying, here I can see the circle, here I can see these points. So from these points, I will draw horizontal and vertical lines. So first I will draw the vertical lines. So one vertical line I can draw here like this, and one vertical line I can draw like this. So these lines should be passing from these dots. And then I will draw the horizontal line which should be passing from both of the dots. Now this line is cutting twice on x-axis and once on y-axis, right? Twice on x-axis, once on y-axis. That's it. Twice on x-axis and once on y-axis. Let's see other example. 1, 2, 3 dots are there. So one line I will draw like this. Second, third. Now what I will do? From passing all these 3 points, I can draw another line. So it is cutting thrice on x-axis and once on y-axis. Thrice on x-axis, once on y-axis. Here what I can do? One line from this point and one line horizontal. So it is cutting once on x-axis and once on y-axis. You will not say that, sir, it is cutting twice on y-axis. No. Only one side you need to see. This side x, this side y. So only one side you need to see. So once on x-axis, once on y-axis. TM11. Here what you will do? You will draw a line like this. From both of the points it is passing, and horizontal if you draw, then one line and the other line. Straight line I need to draw. So once on x-axis and twice on y-axis. Once on x-axis, twice on y-axis. That's it. Let's see more. Here what I can see? 1 dot, 2 dot, 3 dot and 4 dot. So what I will do? One line like this, one line like this, and on horizontal as well, one line like this and one line like this. So it is cutting twice on x-axis and twice on y-axis. Which mode it is? TM. Twice on x-axis, twice on y-axis. TM22. It will never happen that TM10 would come, TM0 would come, 01, 02 would come. These will never happen because these are the non-propagating mode, right? So these modes will never come. So did you understand the point? If you are able to see the half cycle clearly, here I cannot see any half cycle, here I cannot see any half cycle, but here I can see the half cycles. So if I am able to see the half cycles clearly, then it is TE, otherwise it is TM. Then how to tell MN values? So here by number of half cycle I will tell, and here what is the trick? That I will draw the dots, then I will join vertically and horizontally. How much time it is cutting? Then from there I can tell the MN value. So let's see the clubbed problem. You need to tell the modes. So how will you tell the modes? In this question what I can see is that I can directly see the half cycles. 1, 2, 3, 4 and 5. So certainly this is T. 5 half cycle I can see in X direction, and half, one half cycle I can see in Y direction. This is half cycle and half cycle, right? So T51. Let's talk about this one. Can you see any half cycle like this? No. These are no half cycles there. What I can see the dots here. I can see the dots. So without even drawing the lines also you can tell. Like if I draw the line, then one will cut here, other one will cut here, 3, 4, then horizontal 1, 2. So vertically 1, 2, 3, 4. So certainly it is TM because I cannot see any half cycle. So 4 times on x-axis and twice on y-axis. So TM42. Okay, very easy. TM42. What about this one? Here also you can see the dots. So without even drawing the line, you tell me why it is TM? Because you cannot see any half cycles. Now what will be the number? What will be the value of M? If I draw the line 1, 2, 3, 4, 5. So on x-axis it will cut 5 times. On x-axis it will cut 5 times. And on y-axis it will cut only once. So TM51. I hope you are able to visualize it. 1, 2, 3, 4, 5. So this is 5 times on x-axis and once on y-axis. What about this one? Here you can see half cycles. 1 half cycle, 2 half cycle, 3 half cycle, 4 half cycle, 5 half cycle and 6 half cycle. Certainly it is T. So 6 half cycle you can see in x direction and 0 in y direction. So it is T60. This is how you need to tell. So we have built a problem solving technique to solve these kind of problems. Here I am not giving you the visualization of TE51 mode. In this world, no one can give you the visualization of these TM51 modes, TE51 mode. No one can give you the visualization because it is very tough to visualize. We have given the visualization of TE10 mode, right? And then we build a problem solving technique that if these kind of questions are asked, then how will you solve the problem in the examination? Is that clear to you? Now we need to solve the assignment on those waveguide parameters. So in assignment as well, we will learn a lot of new things. So this is the assignment. I can show you the problems, then you can start solving it on your own. That's it. These are the problems which we need to solve in this video only. In this video only, we will solve the assignment as well. So again, I will have to pause because एकले का problem बहुत बढ़ रहा है यार. But I need to deliver the videos, so that we will deliver anyhow. But please cope up with it. Like if I am not able to speak properly, then please cope up with it and just study. Okay? Yeah. So we will start the assignment in the second half of this video. I will pause the video. You can also take a break. You can try solving these problems and then come back. Okay, so let's start the assignment now. First question, very easy. In dominant mode, that means TE10 mode is there. Dominant mode has been mentioned, so it is TE10 mode. Breadth is given, that means A value is given, that is 10 centimeter. The guide wavelength for a signal of 2.5 gigahertz, that means frequency is given 2.5 gigahertz. And what you need to find? You need to find lambda g. So whatever that is given, that you write down, and whatever that you need to find, that you need to write down. So lambda g I need to find out. So lambda g is equals to, so this is method 1. There are two methods of this question. This is method 1. Lambda g is equals to lambda upon under root 1 minus fc by f. So whenever I see this question, this will be the first thing that will click to me, that lambda g is equals to lambda upon under root 1 minus lambda upon under root 1 minus fc by f whole square. So this is the first thing that will click to me. F value I am having, lambda value I can calculate, anything I can calculate. The first thing is fc. So fc I don't know. So fc is equals to vp by 2a. Since they did not mention anything, so I will take as free space only. So 3 into 10 to the power 8, 3 into 10 to the power 8 divided by 2a. A is 10 centimeter, which I can write down as 10 to the power minus 2. A is 10 centimeter, right? So this becomes 10 to the power. So from here I get to know that it is becoming 1.5 gigahertz. You can solve this one. 10 to the power 10 it will be, and then 30 by 20, 1.5 gigahertz. So your fc value is 1.5 gigahertz. Now lambda value also I am not having. What is lambda? Lambda is the wavelength of open space. If the wave was propagating in open space, then what would be the wavelength? So lambda value. What is lambda? Lambda is equals to Vp by f. Lambda is equals to Vp by f. This we already know. So what is your Vp? 3 into 10 to the power 8. And what is your f? 2.5 gigahertz. So whether it is open space or in waveguide, f will never change. Omega never changes. Omega never changes, right? So if you solve this one, what you are getting? 10 to the power minus 1. Here 30, 300 by 25. 300 by 25, which is 12 centimeter. So lambda value you are getting is 12 centimeter. You can solve this one, you will get 12 centimeter. So lambda value you are getting 12 centimeter. All the values you are having. Now you can put the lambda g. So lambda g is equals to 12 centimeter upon under root 1 minus fc by f. So that is 1.25 divided by 2.5. 1.25 divided by 2.5 whole square. That is equals to 12 centimeter divided by under root 1 minus 15 by 25. What that would be? 3 by 5 whole square. So 25 minus 9, 16, and 4, the side would be 25, 5, 16 minus 9, 3 centimeter. So that would be 15 centimeter. So this is the answer. Okay. What could be the method 2? What else I know? I know this formula. 1 upon lambda square is equals to 1 by lambda c square plus 1 by lambda g square. This formula fc is equals to vp by 2a. I wrote it down for TE10 mode because I told you to remember this one. Similarly, here I need lambda c. So lambda c for TE10. I asked you to remember this one. What was the formula? 2a. Directly I asked you to remember this one. So 2 into A. What is A? A is 10 centimeter. So here it will be 20 centimeter. So this is your lambda C. And what will be lambda? Lambda will be Vp by F. So 3 into 10 to the power 8 divided by 1.5 gigahertz. So lambda value here we calculated, that was coming out to be 12 centimeter. So what I need to find? Lambda G I need to find. So 1 by lambda G square would be equals to 1 by lambda square, that is 1 by 12 centimeter square divided by 1 by 20 square. So you can do this calculation in your calculator and you will get the same answer only. But let me do it again. You can also do it. So I just need to tell you the step, how will you do it. So first you will do the 12 square, then you will take the reciprocal, then you will put minus, then you will put the bracket, then you will, 20 square is 400, then you will write down 400 and take the reciprocal. Then minus has been done, and then you know that you need to take the under root. So then you will take the under root. After that you need to do the reciprocal, then reciprocal. So 15 centimeter. So only in one step I did the calculation in the virtual calculator. So this is the thing, that's why I was doing the calculation. So you should have the enough practice. For this one you require enough practice. You can watch 100 videos on how to use virtual calculator, but if you have the practice, then you will be able to use it quickly. Otherwise you will take time. Like what guys usually do is that first they will solve this one, then they will solve this one, then they will put in the calculator 1 by 144 minus 1 by 400, and then they will subtract, then they will take under root, then reciprocal. But in one step only you should have the habit of doing it. So lambda G we are getting as 15 centimeters. So there were multiple ways, you can choose anything. So this was your answer. Okay. So two methods I have told you. Right. Let's go to the next one. Yeah, this is a good question. Omega beta diagram you need to know, or you need to draw, or beta omega diagram also you can draw for rectangular waveguide. So here beta means beta G. So beta G is equals to beta into under root 1 minus omega omega C upon omega square. Right. Now the thing is this the function of between beta and omega? No, I told you. What is the scene? That beta is also a function of omega, no? This is not the relation of beta G and omega, but beta is also a function of omega. So what will happen is that this is a function of omega. What is beta? Beta is omega by Vp divided by omega square minus omega C square divided by omega, because omega square minus omega C square divided by omega square. So when you take the under root, you will get omega only. Omega get cancelled. So this is the exact relation between 1 by Vp under root omega minus omega C square. So this is the exact relation between beta G and omega. Now you need to draw the graph. I can draw the graph now. Beta G versus omega. Now you tell me one thing, before omega equals to omega C, beta G will be 0, because there will be no propagation. If there is no propagation, that means beta is 0. So for omega less than omega C, beta G will be 0, because this value will be imaginary, which is not possible. So omega beta G will be 0. Now for omega greater than omega C, this will be the relation. So if omega increases, that means beta G value increases. If omega is 1, then it is 1 minus omega C square. If omega is 2, then 4 minus omega C square. So if omega increases, then beta G increases. So the graph can go like this as well, and it can go like this as well. So this is graph 1, this is graph 2. Which graph is correct? Basically, let me show it again. The graph can increase like this, because increasing value of omega, beta G will increase, or the graph can increase like this as well. Graph can increase like this as well. So which value is correct? Which graph is correct? First or second? Use your mathematics and answer this question. This thing I have answered in network analysis as well, and in analog electronics as well. When I was teaching both of the subject, I told you how to understand the nature of graph. And if you have studied mathematics, then also you can tell the nature of graph, whether it will be increasing like this or like this. This is my question. And both of the options will be there. Like if this question come in the examination, then one option will be like this and other option will be like this. then which option you will click? So how I will check? I will check the slope, because as per this graph, slope at omega equals to infinity will be some finite. Slope at omega equals to infinity. This is what you call slope, right? This is what you call slope. So as omega increases, the slope decreases. For which graph? For second graph. For second graph. And as omega increases, the slope increases. For which graph? For the first graph. Because here this is the slope, then this is the slope. Now the slope is going towards infinity. So for first graph, the slope is increasing. Let me make it again. There were two possibilities. That this was your possibility for graph 1, this was your possibility for graph 2. This is your graph 1 and this is your graph 2. So in the graph 2, if you see that if omega value is increasing, the slope is going down. Slope is going towards 0. And here the slope is going towards infinity. That means slope is increasing only. I hope you know what is the meaning of slope. This is your slope. So here slope is going towards 0, but here the slope is going towards infinity. So now I need to find the slope. So in graph, whenever you need to know the nature, the only thing is find the slope. Del beta g divided by del omega. Just find that. What you will get? Del beta g divided by del omega. What is this, by the way? 1 by Vpg. And what would be the formula of 1 by Vpg? Can you tell me? That would be equals to 1 by Vp under root omega square. Let's write down here. So what I am calculating now? Del beta g divided by del omega. That would be equals to 1 by Vgg, sorry, not Vpg, sorry, 1 by Vgg, sorry, really sorry. This will be our guided group velocity, right? Or you can directly calculate the slope as well. Forget about it, just calculate the slope. Forget about all these things, just calculate the slope. What you will get? So if you are calculating the slope, this is your 1 by 2. So 1 by 2 will come this side, and downward you will be getting under root omega minus omega c square, and here you will be getting 2 omega. So 2 and 2 get cancelled, omega can go downward. So what you are getting? 1 by, here I am writing down, 1 by Vp under root 1 minus omega c divided by omega whole square. Or you could have directly seen that this is d omega by d beta by d omega. What is that? This is our group velocity only. What is this? This is our group velocity for guided medium. Group velocity for guided medium. This is the reciprocal of a group velocity for guided medium, right? So what is the formula of group velocity? This is the formula. So that formula directly you could have written, or you could have calculated the slope as well. So what do you see here? As omega increases, this value goes down. So under root 1 minus something is going down. That means this value is going up. And if this value is going up, that means this total value is going down. Are you getting this point or not? As omega increases, then this value goes down. If 1 minus something is going down, that means this complete value is going up. Because 1 minus 0.1 will be 0.9 and 1 minus 0.2 will be 0.8. So as omega increases, this value increases. From 0.12 we are going to 0.2. So under root 0.8 we will get. Initially we were getting under root 0.9. Now I will get under root 0.8. So this value is getting what I am saying. As omega increases, this value goes down. Sorry, opposite I said. Initially we were getting 0.8 because initially the value was 0.2. Omega c by omega value was 0.2. Now what has happened? Omega has increased. So if omega has increased, then this value has gone down. So this value has gone down, that means it has become 0.1. Now I am getting 0.9. So now I am getting more value. If I am getting more value, that means this total value will be lesser. This total value will be lesser. So as omega increases, d beta g by d omega is going down. Then which graph is correct? This one. Second graph is correct. So this is the way of analyzing it. So two possibilities will be there, and both of the options will be mentioned in the examination. So you need to see that as omega increases, the slope is going down. That means slope decreases. So if slope decreases, then how will I make the graph? So graph cannot be made like this. It has to be made something like this. Note the complete curvature. This is how I should make the graph. Okay, so this is the graph between beta g and omega. Did you understand the point? This was a good question about the nature of the graph. So nature of the graph you will always understand by taking the slope, right? And at omega equals to infinity, the slope will be 1 by Vp. At omega equals to infinity, if you put omega equals to infinity here, what you will get, this will be 0. So slope will be 1 by Vp. So slope is not 1. That slope is not 0. Sorry. At omega equals to infinity, the slope is not 0. If slope was 0, then I would have made the graph like this, the flat line. But there is no flat line. The slope will keep on increasing and it will stop at 1 by Vp. So maximum slope will be 1 by Vp. So slope will keep on increasing. It is never saturating. The graph will never saturate. Like it is not like a RC circuit. In RC circuit, graph goes like this, right? So it will never saturate. It will increase like this. That's why I ignored this kind of curve. So that's why I made it by my pen only, that it will increase like this. Okay. So slope at omega equals to infinity is 1 by Vp only. Right. So this was the question. Let's see the next one. Ratio you need to find neta TE upon neta TM. So neta TE, if you remember, neta TM we remember by a trick. What is the trick? TM, team. So with team you need to stand. Right. And what about TM? Neta divided by under root FC by F whole square. They are asking neta TE by neta TM. For both of them, the cutoff frequency will be same. What is the formula of cutoff frequency? FC is equals to Vp by 2 M by A whole square plus N by B whole square. So this has nothing to do with TTM mode. If both of the modes are existing, then it will depend only on the value of M and N and Vp. So it has nothing to do with the mode. I told you only formula different between TE and TM is neta. Rest all the formulas are same. Beta G, lambda G, VPG, VGG, all those formulas are same. Only this neta formula is different. So FC formula is also same. For both of them, FC formula is also same. So if FC formula is same, then you just need to find the ratio. Neta TE divided by neta TM. Right. So neta TE divided by neta TM. So what you are getting, if you take the ratio, then 1 minus FC by F whole square. So if you calculate it, what you are getting is that 1 minus 1 upon 1.5 whole square. So 1 by 1.5, 1 by 1.5 whole square minus 1 plus minus then under root. ये क्या हो गया? Am I doing something wrong? Here I have written 1.34. Oh, there is no under root, sorry. Let me do it again. 1 by 1.5 whole square minus 1 plus minus reciprocal. 1.8 we are getting. Are we doing anything wrong? Neta TE upon neta TM. Neta TE will be neta upon cos theta T upon neta TM. So neta TM will be neta upon neta into cos theta T. So we are getting 1 minus FC by F whole square, right? Under root will be full value only, 1 minus FC by F whole square. So 1 upon FC by F whole square. F is 1.5. So 1.5 reciprocal whole square minus 1 plus minus 1.8 will be the answer, not 1.34. Okay, answer will be 1.8. Really sorry for the error. Answer will be 1.8. Okay, there was some error from my side, so that would be the answer. Answer is 1.8. Okay, let's see the next one. Find mode. Very easy question. So here AB value is given, you need to find the mode. So EZ value is existing. If EZ value exists, then which mode it is? Transverse magnetic. EZS is non-zero. That means certainly HZS has to be 0. So which mode it is? Magnetic field is transferred. Now you need to find Mn value. So what you can see here, what is written? M pi by A. So M pi by A is equals to 40 pi. What is written here is that M pi by A is equals to 40 pi. And what is A? A is 5 centimeter. So pi and pi get cancelled. From here M value is 40 into 5 centimeter. That is 2. This is your M value. And what about N pi by B? So N pi by B is equals to 50 pi. Pi and pi get cancelled. So N value is 50 into B. What is B? 2 centimeter. That is 1. So Mn value 21. So Tm 21. That's it. This is the mode. So this kind of question we have seen where you need to analyze whether it is TE or Tm. But here they have asked the value of Mn as well, which was very simple. M value was 2, N value was 1. So Tm 21. Right? Let's see this one. Cutoff frequency of dominant mode they are asking. Cutoff frequency of dominant mode they are asking. So FC for TE02 they have given. FC for TE02. So what will be the formula? Vp by 2 under root 0 by A whole square, M by A whole square plus N by B whole square. So what you are getting? Vp by 2 into 2 by B. That would be Vp by B. And that is equals to 12 gigahertz. That means 12 into 10 to the power 9. So here there is no medium mentioned. So I will take by default, I will take which medium? I will take free space only. So 3 into 10 to the power 8 divided by B is equals to 12 into 10 to the power 9. So B value I am getting as 2.5 centimeter, right? 3 by 12, 1 by 4, 0.25 into 10 to the power minus 1. So into 10 to the power minus 1, yeah, 2.5 centimeter. So this is the value of B you are getting. That means A value is twice of that. So A value will be 5 centimeter. So value of A is coming out to be 5 centimeter. What I need to find? FC I need to find cutoff frequency for dominant mode, which is TE10. That is equals to Vp by 2A. So 3 into 10 to the power 8 divided by 2 into A, 5 centimeter, 10 to the power minus 1, 3 gigahertz. Here I do not even need this value Vp because eventually it will be getting cancelled. I just now noticed it. Let's just say I take Vp as Vp only here. You can solve it, take Vp as Vp only and then find the value of B in terms of Vp. So what you will be getting? Vp by 12 into 10 to the power 9. So what will be your A value then? Twice of this. Then here what you are going to put? Vp by 2A. So 2 into Vp, 12 into 10 to the power 9. So what will happen here? Vp and Vp get cancelled. So 12 by 4 will be 3 gigahertz only. So Vp and Vp is actually getting cancelled here. You do not even need to take Vp as C. Are you getting this point? So Vp and Vp will get cancelled. This is a very simple thing which you can do it on your own. Right? So it was not necessary that I put 3 into 10 to the power 8. Let's see the next one. Calculate the single mode frequency range for rectangular waveguide of 4 centimeter into 3 centimeter dimension. Yeah, this is something new. Single mode frequency range. So let me tell you what is this single mode frequency range. Now A value is 4 centimeter and B value is 3 centimeter. Now you just let me know one thing. What is your lowest cutoff frequency? What is your lowest cutoff frequency? That is of your dominant mode only. This is your lowest cutoff frequency. If my mode was TE10, then my cutoff frequency has been lowest. So this is my lowest cutoff frequency. So Vp by 2A. So 3 into 10 to the power 8 divided by 8 into 10 to the power minus 2. So 30 by 8. 30 by 8, which is very simple, but still I will use the calculator. 3.75 gigahertz. So that means if I apply 3.85 gigahertz, if I give this as my EM wave frequency, if this is my EM wave frequency, then certainly TE10 mode will propagate. And now what they want? They want only single mode propagation. Calculate the single mode frequency range, or you can say single mode means they want only one mode to be propagated. Single mode propagation frequency range. Here propagation word should also come. Okay, propagation word should also come. Single mode propagation. They want only one mode to be propagated. This is what they want. So at the minimum frequency, if you are applying any frequency lesser than 3.5 gigahertz, if you are applying any frequency lesser than 3.5 gigahertz, let's just say I apply 3 gigahertz frequency, my EM wave is coming with 3 gigahertz frequency, then no mode will be propagated, neither TE10, neither anything, because minimum you need, if this is your dimension, then minimum you need 3.75 gigahertz frequency. Do you agree to this point? Now above that, above 3.75 gigahertz, more mode can also be there. So this is the lowest cutoff frequency. What will be the second lowest cutoff frequency? Second lowest. Think about it. Second lowest cutoff frequency. What do you think? It could be TE01. It could be TE20 as well. Look. It could be TE01, because what will be the formula for TE01? Or it could be TE20 as well. Let's find out the formula for both of them. Why I am saying so? These two are in the race of being second lowest cutoff frequency. Why I am saying so? Let's find out the formula. What will be the formula? Vp by 2 under root m by a whole square, that would be 0 by a whole square, plus 1 by b whole square. So what you will be getting, because n value is 1, n value of 1 I have put here, so what you will be getting? Vp by 2b. So what you are getting? Vp by 2b. And here what you will get? Vp by 2 under root m by a, that is 2 by a whole square, plus 0 by b whole square. So what you will be getting? 2 by a. So answer will be, this is Vp by 2 into 2 by a. So answer will be Vp by a. So what will be the answer? Vp by a. So here your cutoff frequency will be Vp by a. Now if your a was greater than 2b, let's just say a was greater than 2b. What I am saying is that my a was, let's just say 6 centimeter and b was 2 centimeter. Then what would be the answer here? Vp by 6. And what would be the answer here? Vp by 4. Which value is larger? This value is larger. Vp by 4 is larger than Vp by 6. And what you need lowest cutoff frequency. Like this will be the lowest one. After that, which is lowest? This is lowest. After that, this will come. So that will be the case for a greater than 2b. Right? But now what is the scene? The scene is value of a is 4 centimeter. Value of a is 4 centimeter. So this will be Vp by 4. And what this will be? Vp by, and value of b is 3 centimeter. So 3 into 2, 6. So this is your Vp by 6, this is your Vp by 4. Right? So which one is lowest? This is lowest, no? If I put the value 6 centimeter it is. This is also 6 centimeter. So if I put the value 3 into 10 to the power 8 divided by 6 into 10 to the power minus 2. So 300 by 6. So this will be 5 gigahertz. And what about this guy? This is 3 into 10 to the power 8 divided by 4 into 10 to the power minus 2. So this will be 30 by 4. So that should be 7.5 I guess. 30 by 4 is 7.5 only, you know. Don't trust on yourself. 7.5 gigahertz. So this is the lowest. The second number is this, and this is the third number. Are you getting this point? So always check for these two, FC TE01 and TE20, because depending on the AB value, the things could be different, right? So always check for both of them, 01 and 20. Here this came second, but it is not necessary that always this will come at second. Why is that so? Because if A is greater than to B, then the scenes will be different. Then this guy will come as second. Are you getting this point? So always check for, after TE10, always check for TE01 and 20. Are you getting this point? So some conclusion I can write down. Now first write down the answer of this question. So what do you see? This is the minimum and this is the second one. So let's just say if I give my frequency as 4 GHz, then at 4 GHz TE10 will propagate for sure, but TE01 will not propagate. And now let's assume I give my frequency as 4.99 GHz, then certainly TE10 will propagate, but this will not propagate. Now if I give my frequency as 5.01 GHz, so TE10 mode will propagate and TE01 mode will also propagate. What I want? Only one mode propagation I want. So that means I need to keep above 3.75 and below 5. Are you getting this point? I need to keep above 3.75 and below 5, because if I keep below 5, then only this mode will be propagated. But if I keep more than 5, that means this mode will also come and this mode can also come. And if I keep more than 7.5, then this mode will come, and this mode will also come. So what they want? Single mode propagation. So for single mode propagation, frequency range would be 3.75 GHz to 5 GHz. So if this is my frequency range, if this is my range, that means if this is your bandwidth, which bandwidth? This is your 3.575 gig and this is your 5 gig. This is your frequency. If this is your bandwidth, then in this bandwidth only TE10 will be propagated. Okay, they can ask you the bandwidth as well. What is that bandwidth? 5 minus 3.75, that would be 1.15 gigahertz. So this bandwidth also they can ask, that what will be the single mode propagation bandwidth. Did you understand this point? Also, what conclusion did you make? That if A is less than 2B, then cutoff frequency for TE10 will always be lowest. Then which value will come? TE0 will come, 01 will come, and then which value will come? TE20 will come. And if A is greater than 2B, then certainly FC TE10 will be lowest. Then which value will come? TE20 will come, because if A is greater than 2B, then this value will be lower. FC20 will be lower and this value will be higher. And then which value will come? FC T0 would come. And if A is equals to 2B, then what will be the scene? Certainly always lowest one will be TE10. But then TE20 and TE01 will be equal. Why is that so? Why both are equal? Because if you put A equals to 2B here, so what will be the equation? Cutoff frequency will be Vp by 2B. Here also it is Vp by 2B only. So both will be equal, right? So this you do not need to remember, because in the examination you will be getting confused. So better you derive this thing. You write down the cutoff frequency for this one, you write down the condition for this one. Then here directly you will get to know that if my A is greater than 2B, if my A was greater than 2B, then this cutoff frequency would have been lower. This cutoff frequency would have been lower. Then you can write down this equation. If you can write down this equation, then certainly you can write down this one as well and this one as well. So usually people remember it, that if A is greater than 2B, then what will be the cutoff frequency, then what will be the order of cutoff frequency. But you don't need to remember, you don't need to mug up. You can derive it very easily, because if you mug up, then error may happen, but if you derive it within seconds, there will be no problem, right? So this is the meaning of single mode propagation, and secondly we have seen this order as well, right? If you have good enough practice, then eventually it will be remembered that if A is greater than 2B, then 2 0 will come first. If you have good enough practice, but since it is the last time, you will have less practice only, so better derive this thing in the examination. Just write down the expressions, you will be able to understand. Let's move to the next one. So FC cutoff frequency is given for TE30 mode, that is 18 gig. You need to find the border wall dimension, that means value of A you need to find. What I need to find, because always A is greater than B, this I already know. In our waveguide we always take A greater than B. So what I need to find, value of A I need to find, because broader wall direction they are asking. Which wall is broader, that means A is greater than B, so A value they are asking, right? So FCTE30 they are asking. So that would be Vp by 2 under root m by a whole square plus n by b whole square, that would be 0 only. So what we are getting, Vp by 2 into 3 by a, that is equals to 18 gig. Nothing is mentioned, so I will take this as 3 into 10 to the power 8 only into 3 divided by 2a is equals to 18 into 10 to the power 9. So a is equals to 9 into 10 to the power 8 divided by 36 into 10 to the power 9. That will be 1 by 4. 1 by 4 into 10 to the power minus 1, 0.25 into 10 to the power minus 1. So another one, so 2.5 centimeter. That's it. This is the value of A. Very simple question, formula based, directly formula based. We have seen the questions on equation already in our second lecture, right? We have seen the questions on field pattern in this lecture only. We have seen the questions on power calculation in the last lecture. Only the waveguide parameters questions were left. So those we are seeing here. If you need to see the power calculation question, then you need to watch the previous video. If you want field pattern question, then in this video only we have covered that. And if you want those wave equation questions, like which wave is what, whether it is T mode, TM mode, which mode is there, how to analyze HX equation, how to analyze EX, EY equation, EX is a function of cos X sin Y. So those things if you need to learn, then you need to watch the second lecture, right? Here we are only seeing the questions on waveguide parameters, nothing else. Let's see the next one. Rectangular waveguide dimension are this. How many modes of energy transfer are possible at 20.5 gigahertz? This is also a very good question. So my wave is propagating with this frequency. Parameters are given. Now I need to tell which all mode can be propagated. So for that, what I need to find? Cutoff frequency I need to find. Because if my frequency is, if my f is greater than fc, that means, or I can say, if my cutoff frequency is less than 20.5 gigahertz, that means propagation is there. So I need to find the cutoff frequencies. So how I will start? So first I will find the cutoff frequency of TE10, that I already know. So I will go step by step, like TE10, 20, 30 I will find. Then what I will find? Then I will find for TE01, 02, 03. Then what I will find? Where m and n both are not equal to 0. So first I will find the cutoff frequency for TE-M0, right? Why I am not finding for TM-M0? Why I am not finding for TM-M0? Because this does not even exist. TM can never be 0, so TM-M0 never exists. So that's why I am not finding for TM-M0. I am not finding for TM-M0. So I am only finding for TE-M0. So let's start finding it. For TM-M0 I am finding. So first I am finding cutoff frequency for TE10, because TE00 can never exist. So what is the cutoff frequency of TE10? That is Vp by 2a. So 3 into 10 to the power 8 divided by 5 into 10 to the power minus 2. So 30 by 5, 6 gigahertz. You are getting 6 gigahertz. So what will be for 20? That would be Vp by a under root 2 by a whole square. N value is 0 only. So that will be 0 only. So what you are getting? Sorry, this was Vp by 2. Really sorry. This was Vp by 2. So what you are getting? Vp by a. So this was your Vp by 2a. That was 6 gigahertz. If you calculate Vp by a, then what you will get? 12 gigahertz, just the double, right? If I calculate cutoff frequency for 30, so what I will get? Vp by 2 under root 3 by a whole square, right? And plus 0, that I don't need to write. So what I am getting? 3 Vp by 2a. So thrice of Vp by 2a. Thrice of Vp by 2a. What is the value of Vp by 2a? That is 6 only. So now you are getting thrice of that. So what you are getting? 18 gig. So what will be your FC for TE40? For 10 you are getting 6, for 20 you are getting double, then 18. So here you will get 4 times 6 into 4, 24 gigahertz. So this will not propagate. This will not propagate because the cutoff frequency, because the frequency we are having is 20.5 gigahertz only. So this will not propagate, but this will propagate, this will propagate, and this will propagate. So 10, 20, and 30 will propagate. Now I do not need to check M0. Why is that so? Because 50, 60 certainly will not propagate. So now I will start with 0n now. So what I will start with now? TE0n. This I need to check now. So for TE01, first I am calculating cutoff frequency of TE01. So that would be Vp by 2 under root 0 by a whole square plus 1 by b whole square. So what that would be? Vp by 2b. So 3 into 10 to the power 8 divided by 2b. What is b? 1.5 into 10 to the power minus 2. So we are getting 10 gigahertz. What about FCTE02? So what will be the formula? Vp by 2 under root m by a, that would be 0 only, divided by 2 by b whole square. So what you will be getting? Vp by 2 into 2 by b. That is Vp by b only. Vp by b. So Vp by 2b was 10 gigahertz. So what will be Vp by b? Twice of this. That would be 20 gigahertz. So what about your FCTE03? That would be Vp by 2 into 3 by b. So that would be thrice of Vp by 2b. So what that would be? 30 gigahertz. So this will not propagate. Only these will propagate. So step by step you need to go. Now here TM0n is not possible as well, right? TM0n is not possible. 0 small n. TM0n is not possible, and here TM M0 is not possible. So that's why I did not calculate for all these two. Now what I will calculate? I will calculate for TEMN and TMMN. And both will be same only, no? FC4, if I calculate FC4 TE11, or if I calculate cutoff frequency for TM11, both will be same only, no? Because what is the formula? The formula is this: Vp by 2 under root m by a whole square. What is m? M is 1 only. So 1 by a whole square plus 1 by b whole square. Right? So here if both of the modes are propagating, then cutoff frequency will be same. So what will be the answer? 3 into 10 to the power 8 divided by 2 under root 1 by 2.5. 1 by 2.5 whole square plus 1 by 1.5 whole square. Now you know one thing, this was in centimeter. So here also centimeter square will be there, here also centimeter square will be there. So that centimeter square will come out. What that would be? Centimeter only. So here 10 to the power minus 2 will also be there. Are you getting this point? Did you understand what did I do here? This was in centimeter, but we need to put in meter only. So that's why I am adding 10 to the power minus 2. So what you will get? So 2.5 whole square reciprocal plus 1.5 whole square reciprocal. Then take the under root into, so 11.66 we are getting, 11.67 gigahertz we are getting. Let me do it again. 6.25 under root plus 11.66 we are getting. So 11.66 gigahertz. That is correct. So this is for TE11. Now I can go 1-2 as well, or 2-1. 1-2 or 2-1. So first I will go 1-2. FC TE12, or you can say FC TE TM12. Why I am going 1-2? Why I am not going 2-1? After that, let's calculate 2-1 as well. But better we should go with the certain way, like 1-2, 1-2. So 1-3, 1-3. Then next I will calculate 1-4, and here I will go now. 1-1 has been already covered, so 2-1, 2-2. In that manner I need to proceed. So what I need to write? Vp by 2 under root 1 by a whole square. A is 2.5. 1 by a whole square plus 1 by b whole square. 2 by b whole square. Yeah, so after calculating this, we are getting as 20.88 gigahertz. So will this propagate? No, certainly this will not propagate because we have 20.5. So do I need to calculate for this one? TE13 or TM13? No, I do not even need to calculate for this one. Why is that so? Because this will also not propagate. Because TE13 will certainly have more cutoff frequency than TE12, because here 3 will come. So certainly the value will increase only. So I do not need to calculate for 13. So that task is done. 11, 12, 13 is done. Now where I need to go? 2-1, right? FC TE21 I need to go. That will be same as FC TE TM21. So what that will be? Vp by 2 under root 2 by 2.5 whole square plus 1 by 1.5 whole square. So what you are getting? 2 by 2.5 whole square plus 1 by 1.5 whole square at 1 by square 1.5. Yeah, then you need to take under root into 15. So that is coming out to be 15.62 gigahertz. So that can propagate. So now next also I need to calculate. So T22 I should calculate, or TM22. What that would be? Vp by 2. So here I have fixed 2 now. Initially what did I fix? 1 I fixed. Now I have fixed 2, and now I am increasing 1 1 I have put here, 2 2 I am increasing. Here 1 1 1 1. Here 1 was fixed. So value of n was 1 here. Here the value of n was 2. Here the value of n was 3. Now this 2 is fixed. So value of n is 1. Here value of n is 2. So this is how I am checking. So step by step I need to check. 2 by 2.5 divided by 2 by 1.5. Do I need to check the value for this one? Because I know that this value was greater than 20.5 gigahertz. Then certainly this will be greater than 20.5 gigahertz, you know. Are you getting this point or not? If this value was greater, that means here 1 was there, but here there is 2. This portion is same, this portion is same, only this portion is different. So this portion is larger than this one. So certainly it will be greater than 20.5 gigahertz, or you can say it will be greater than 20.88 gigahertz. So if it is greater, then certainly it will not propagate. So next I don't need to calculate, right? So only this is propagating. Now I need to calculate for 3-1 as well, because now I am fixing 3. So 3-1 I am calculating. So 3-1 we are calculating. So what we will be getting? Vp by 2 under root 3 by 2.5 whole square plus 1 by 1.5 whole square. So 3 by 2.5 whole square plus 1 by 1.5 square. 3 by 2.5 whole square plus 1 by 1.5 square under root into 15. So that is coming out to be 20.59 gigahertz. So So that will also not propagate. So do I need to check further? No. Do I need to check TE41? No. Because next anything will not propagate. Why is that so? Because 4.1 will be larger than 3.1. 4.1 will be larger than 3.1. Right? Then 4.2 will certainly be larger. Here 3.2 will also be larger. So 3.2 also I don't need to calculate. So this was the last one which I need to calculate. That's it. So from here what did I get to know? 1, 2, 3, 4, 5, 6, 7, 8 and 9. These 9 are propagating. So 9 modes are propagating. 9 modes are propagating. What is the order? So initially TE10 will come. Then after 10, TE10 was having 6 gigahertz. Then 12, 18. Here you are having 10 and then 11.66. Then TE01. TE01. Then TE11. Then TE20. Right? Charging complete. Then TE20. So 6, 12, TE20. This is having 18. Here it is having 15.62. Then TE21. Then TE21, which is equivalent to TM21. Then this was having 15. 11.66 is also covered. 02 will come later on. First 30 will come. And TE30. Then TE02. 1, 2, 3, 4, 5, 6, 7, 8. TE02. 30 and 02 I have written. So which one I forgot? 21, 21 I have written. 11. So TE11 that is equals to TM11 as well. So TE11 is equivalent to TM11 as well. Is equivalent to TM11 as well. Here what was the scene? A was greater than 2B? No. Here A was less than 2B. Here A was less than 2B. This was the scene. So if A was less than 2B, then certainly you know that TE01 should be less than TE20. Is that clear here? Yes, 01 is less than 20. That is also clear. Right? So this was just a fact that I have written. A was less than 2B, then 01 will be lesser than 20. But this is the order. 10, 01, 11, 20, 21, 30, 02. Okay, so this is the order and 9 modes are propagating. 9 modes. So in the examination, more than 9 modes should not come. Like they will not ask too much of mode. They will ask 4, 5, 6. This many only they ask. Maximum they have asked 4, 5 modes only as far as I remember. So 9 modes are too much. So this is the way you need to proceed. So always first calculate the 0, M0 and N0, M0 and 0N. Then you proceed with fix 1, 1, 1, 1, 2, 1, 3, right? 1, 1, 1, 2, 1, 3. Then fix 2, 2, 1, 2, 2, 2, 3. Then fix 3, 3, 1, 3, 2, 3, 3. So if you follow in the order, then you will not forget any of the mode. Otherwise, you may end up forgetting the mode as well. Let's see the next one. It is desired that waveguide only operates in single mode with cutoff frequency 25% above the cutoff frequency of dominant mode, but not higher than the 95% of the next higher frequency, the allowable range. So here what you can see, A is greater than 2B. First thing I can see is that A is greater than 2B. So here certainly cutoff frequency will be the lowest. TE10 will be lowest. Then forget about TE10. TE10 will be lowest. If A is greater than 2B, then whose cutoff frequency will be lesser? 2 zeros will be lesser and 01 will be more. Why is that so? Because FC TE20 is equals to Vp by A and FC TE01 is equals to Vp by 2B. So if A is greater than 2B, then this will be less. This value will be less. So lowest is FC TE10. There is no doubt about that. Lowest is FC TE10. What is the second lowest? Second lowest is FC 20. So what will be TE10? That would be Vp by A. So 3 into 10 to the power 8 divided by 2.29 into 10 to the power minus 2. So 30 by 2.29. You are getting 13.10. So what they are saying, the cutoff, it needs to propagate in single mode only with the cutoff frequency 25% above the cutoff frequency of dominant mode. So this dominant mode is having the cutoff frequency of 13.10 gigahertz. So it should be 25% more. So what should be your range? What I am saying is that what should be your range? This is the next question which we can solve download as well. So your range should be 13.10 is the minimum cutoff frequency, but 25% more, then that means I need to multiply with 1.25, and it should be lesser than 95% of this one. So what will be the 95% of this one? This will be, this was Vp by 2a. Oh, sorry. This was Vp by 2a actually. So divided by 2 will also be there. So 6.55. This would be 6.55. 6.55 gigahertz. This was Vp by 2a actually, not Vp by a. So 6.55. And what they are saying, above the cutoff, but not higher than 95% of the next cutoff frequency. So what will be the cutoff frequency? Vp by a, simply the double of it. What will be the double of it? That would be 13.10. That means you need to take 95% of this one. 13.10 and 95% of this one. Is the language of the question is clear? 25% above than the lowest one and 95% of the highest one. So highest is second lowest. 95% of the second lowest and 25% more than the lowest. So 25% more than, that means 1.25 multiplication, and 95% of the highest one, that means multiplied with 0.25. What they mean to say is that ideally your range should be between 6.55 to 3.10. But just to be sure, I do not want to be at boundary. So what I mean to say is that I will go ahead by some amount and go before by some amount. So that range I will take. This is what they are saying. Now what is this value? This value is 25% above than 6.55. And what is this value? This value is 95% of 13.10. This is what they are saying. Okay, so what you get into 1.25. So here we are getting 18.18 gig. 18.18 gigahertz. And here what you are getting? 13.10 into 0.95. So 12.44. So 8.18 to 12.44, or this is your answer. Is that clear to you? So this range I was requiring, that 8.18 and 12.44. So if I run between this frequency range, then only single mode will be propagated. Right? Let's see this question. If A is equals to 3 centimeter, look, there are three questions. A is equals to 3 centimeter, B is equals to 1 centimeter. A is equals to 3 centimeter, B is equals to 1.5 centimeter. A is equals to 3 centimeter and B is equals to 2 centimeter. Frequency range for dominant mode propagation, that means only one mode should be propagated. You need to find the frequency range for single mode propagation. This is the question. Okay. For single mode propagation, what should be the frequency range? Again, the same kind of question is being repeated, but we will make a conclusion out of it. First question, here A is greater than 2B, right? A is greater than 2B here. If A is greater than 2B, then what I will calculate? T10, that would be Vp by 2A. What that would be? 3 into 10 to the power 8 divided by 3 into 10 to the power minus 2. So that would be 10 gigahertz. And if A is greater than 2B, then next I will calculate 2 0. That would be Vp by A. So 3 into 10 to the power 8. Again I am forgetting to multiply by 2. So this will be 5 gigahertz. This will be 5 gigahertz. And here this will be 10 gigahertz. If I had done Vp by 2B, then what would be the answer? 15 gigahertz would be the answer. But that I don't need. I need the second lowest. So what is the frequency range? Between 5 gigahertz to 10 gigahertz. Here the frequency range is 5 gigahertz to 10 gigahertz. Let's check the second case. A is equals to B. Let's check the second case where A equals to 2B. Here A is equals to 2B, right? A is equals to 2B. So what is the cutoff frequency for TE10 mode? That is Vp by 2A only. So that would be same 5 gigahertz only. But if A is equals to 2B, then you can calculate anything. You can calculate for 20 as well, or you can calculate for 01 as well. What will be the formula? For 20 it will be Vp by A, and for 01 it will be Vp by 2B. Both will be same because A is equals to 2B. So answer will be coming out to be 10 gigahertz only. But for the third case, A is less than 2B. So which you will calculate? For TE10 you will calculate. So what is the frequency range here? 5 gigahertz to 10 gigahertz. So for single mode propagation, this is the frequency range. What about this one? Here this will be same only 5 gigahertz. But since it is A less than 2B, so what you will calculate? FC TE01 you will calculate. So Vp by 2B. So what that would be? 3 into 10 to the power 8 divided by 2B. So here it is 4. So 30 by 4, 7.5 gigahertz. So what is the frequency range you are getting? That is. So here, what did you understand here? That in all the problem our Vp was same. That means our waveguide was same only. Just the parameters were different. Just I changed the value of AB. Then here my range was from 5 to 10 gigahertz. 5 to 10 gigahertz. But here the range is smaller. So if you need the maximum frequency range, for single mode propagation, then you need to put A greater than 2B. So you need to design your waveguide in a manner that your A is greater than or equals to 2B. Are you getting this point? Here the range was 5 to 10 gigahertz. Here the range was 5 to 10 gigahertz. But here the range is lesser. Here your bandwidth is 2.5 gigahertz. Here my bandwidth is 5 gigahertz. And here also my bandwidth is 5 gigahertz. So if I need more bandwidth, if I need to maximize my bandwidth for single mode propagation, then I need to design my waveguide such that A is greater than or equals to 2B. So for A is greater than or equals to 2B, your bandwidth is 5 gigahertz. For this case, your bandwidth is 5 gigahertz. So sometimes in the examination, it is written. Okay, we will see that. Condition for widest possible bandwidth for dominant mode propagation. That is, A should be greater than or equals to 2B. So in one liner, these kind of questions can be asked. That if you need widest possible bandwidth for dominant mode propagation or for single mode propagation, so A should be greater than 2B. So this kind of a fact can be asked in the examination. Okay, yeah. So that's it about this question, and that's it about the conclusion as well. So here we are seeing a few new points. So these points can be seen by the question itself. So these cannot be taught in the concept. Concept has been already taught. Now we are only seeing the questions. Let's see this one. So this was a good question. This was asked in GATE only. Okay, this is GATE PYQ only, but in 90s. And I don't remember the year. So GATE 90s I am asking. GATE 90s I am writing. So I will take a break. You solve this question. And try solving this question as well. This is also easy only. This was also asked in GATE only, but in 90s. Okay. This was also asked in 90s only. So try solving these two questions. Those will be the last question of this assignment and of a rectangular waveguide as well. So rectangular waveguide is also completed, and every single thing regarding the rectangular waveguide we have studied. So try solving these two questions. I will take a break and then I will come back. Okay. Okay, let's start this question. So what they are saying, a 100-meter section of a air-filled rectangular waveguide operating in dominant mode has a cross-section dimension of 1.071 and 0.5 centimeter, and two pulses are there having frequency of 21 gig and 28 gig simultaneously launched. Then what is the time delay difference between two pulses at the other end of the waveguide? So what they mean to say is that this is your waveguide, right? This is your x dimension, this is your y dimension. There would be z dimension as well, right? So what they are saying is that this length is 100 meter. This length is 100 meter. So waveguide is 100 meter long. There in the cross section, the larger length is 1.071 centimeter. So this is your A and this is your B. This is what they are saying. And the mode that is being propagated is TE10 mode. Now what they are asking, what is the time delay difference between the two pulses? So from here two pulses are launched, one pulse and other pulse. Two pulses are launched, one having the frequency of 21 gig and other one having the frequency of 28 gig. Now both will travel with a certain velocity and both will travel the same distance, that is L. So for 21 gigahertz, your time taken will be, the length is 100 meter only, that is L, divided by Vp. Vp1 I am calling it, and this I am calling as T1. So how much time it will take to get to the other end? This is the other end. So how much time it will take? L by Vp1, where L is your 100 meter. L equals to 100 meter. Say yes or no? Why I am writing phase velocity? Why not group velocity? So just remember this thing. When a single wave is being propagated, always write phase velocity. And when the group of waves are being propagated, then you write group velocity. So here single wave, for 21 gig, I will write phase velocity of 21 gig. And for 28 gig, I will write phase velocity of 28 gig. So concept of group velocity is group of waves could be propagated. So if there is group of wave, then you will write the group velocity. Otherwise, you will write the phase velocity only. So here what I will write? Phase velocity only, right? Now what will be my Vp1? My Vp1 will be Vpy. Here they did not mention air field, they have written air field rectangular waveguide. So Vp would be C upon under root 1 minus Fc by F whole square. Because in Vp this come downward, right? And what is your Fc now? Your Fc will be Vp1 by 2a. I am calculating Fc1. I am calculating Fc1. Vp1 guided, sorry. Your Fc will be Vp by 2a only, because 21 gigahertz will also have the phase velocity of Vp only, and it will also have the phase velocity of Vp only. But the guided phase velocity will be different. The guided phase velocity will be different. Why guided phase velocity will be different? Because guided phase velocity depend on this value, 28 gig and 21 gig. It depends on frequency. But this velocity doesn't depend on frequency. This will be same only. Why this is same? Because Vp by 2a, and here Vp will be 3 into 10 to the power 8 only. So here also I should write Vp G1, guided phase velocity. But what is this? This is the phase velocity if it was propagating in open space. I am not saying free space, open space. That means if there was no walls, then what will be the velocity? So in air, what is the velocity? 3 into 10 to the power 8 only, divided by 2a. What is the value of a? 1.071 centimeter. So 10 to the power 2 will be there. So 30 by 2 divided by 1.071. So 15 by 1.071. So that would be 14 gig. So this is your FC. FC will be same for both of them. So your cutoff frequency will be same for both of them. So if I calculate if I calculate T1, that would be 100 by, first let's calculate VPG1. So your phase velocity for 21 gig, what that would be? That would be 3 into 10 to the power 8 divided by under root 1 minus FC by F. So that is coming out to be 4.025 into 10 to the power 8 meter per second. And what will be your VPG2? That means VPG2 I am calculating 428 gigahertz. So what that would be? That would be 3 into 10 to the power 8 divided by under root 1 minus 28 divided by 21. Why I divided by 21? Yeah, okay. 1 minus 14 by 28 because FC is 14 divided by 28. So 3 into 10 to the power 8 divided by under root 1 minus 1 by 4. So let's calculate it only. Three under root into 2, 3.46. So now what will be the time delay? That would be 100 divided by 4.0258 into 10 to the power 8 minus 1 by 100 by 3.46 divided by 10 to the power 8. So what you are gonna get? Reciprocal of this minus 1 by 4.025. So this you are getting 0.04 microsecond, or you can say 40.22 nanosecond. So this is your answer. This is the time delay. So this was very simple. The medium was air. If the medium was air, then what would be my cutoff frequency? That would be Vp by 2a only. So cutoff frequency will be Vp by 2a. Vp value is 3 into 10 to the power 8. 2 into a, 14 gigahertz we are getting. So cutoff frequency is same. Now I need to see the speed. So speed will be c by under root 1 minus fc by f. So for both of them cutoff frequency will be same because both are propagating in the same waveguide. Both are propagating in the same waveguide and waveguide is having the same medium. Then your VPG1 we can calculate and VPG2 we can calculate. The thing is they are having different f. Let me pause the video once. So they are having different f, that means they are having different phase velocities. If they are having different phase velocities, then what will be the time delay? So one wave will reach at some time. Let's just say one wave reaches at x time, the other wave will reach at x plus 0.04 microsecond. So the time delay will be 0.04 microsecond, or you can say 40.22 nanosecond. So one wave will be faster. Which will be the faster one? Which will be the faster one? This will be the faster one, right? One which is having less frequency, one which is propagated with 21 gigahertz, that will be faster. Why is that so? Because its phase velocity is more. If phase velocity is more, that means it will take less time. So this is the faster one, this is the slower one. So this wave will reach before this particular wave. So this wave will take this much time, the other wave will take this much time. But I have written opposite actually. The time difference I need to calculate, no? So mode. Here I can write down the mode. Because time difference I need to calculate. This value will be lower, this value will be larger. But I need to calculate the time difference. So mode I can take. So 0.04 nanosecond. Okay, very easy question. Let's solve this one. What you need to find? You need to find the VSWR. So here what will happen? A wave will come. It will propagate in air. Wave will come. It will propagate in air. Now there is change of medium in between. Here there was air, but here there is a dielectric of having epsilon 4. So if there is change of medium, this is your medium 1, this is your medium 2. And a wave is coming. If there is change of medium, then what will happen? There will be reflection. And incident wave, reflected wave, both combined will make the standing wave pattern. So that VSWR they are asking. So what you need to find? What is my VSWR? VSWR is 1 plus mode of gamma divided by 1 minus mode of gamma. So for mode of gamma, what I need to do? For gamma, what I need to find? Neta 2 minus neta 1 divided by neta 2 plus neta 1. But here neta of guided and that too of TE mode. Neta of guided TE mode. Guided TE mode. Guided TE mode. So here you will not say that sir neta 1 value air that is 120 pi. That answer will be wrong. The value of neta 1 will not be 120 pi. Why is that so? Because some other factor will also come. So let's write down the value of neta 1 TE. So that is for air. So for air, what is the scene? That is equivalent to neta 1 upon TE. So that can come downward. FC1 divided by FC. Now here FC will also be different. Why is that so? Because what is your FC1? FC is VP by 2A. Here what will be your VP? Here VP will be equals to C. In air VP will be equals to C. But here what will be my VP? VP will be equals to C upon under root epsilon r. So that would be C by 2. Are you getting this point? So FC is also different here. Because VP is different, no? So here instead of writing VP, I will write VP1. So what I will get? VP1 by 2A. What is VP? 3 into 10 to the power 8 divided by 2A. A is 5 centimeter, I can see. This is my 5 centimeter. Now here what is written? Here parallel to a pair of parallel perfectly conducting plate of infinite extent. So the scene is the plates are like this. Let me show it on the next page. Plates are extended to infinity like this. They are extended to infinity. Plates are extended to infinity. So what do you think, which value is given? A value or B value? Look, here also we did not care about this 100-meter value. When we studied the waveguide, when we studied the waveguide, when we were studying the waveguide, so we were talking about only AB value. We did not care about this Z value, right? We cared about only this A value and B value. We were not talking about this this length in Z. We were saying that it is infinity. Now here what is the scene? Here this wall is also not there. That means here the scene was 4 plates were there. Here there were 4 plates. Which 4 plates? This plate, this plate, then this plate, and then this plate. Do you remember the matchbox? 1, 2, 3, 4. But here what is the scene? Only 1, 2 is there. So this is known as your parallel plate waveguide. Parallel plate waveguide. Now this is not in the syllabus, but questions are asked on parallel plate waveguide as well. So simply what you need to do? You need to do either you put A equals to infinity or you put B equals to infinity. Anyone you can put equals to infinity. What do I mean to say is that these are two parallel plates that are extended till infinity. So this length is also infinity, and here this length is also infinity. So from upper side also till infinity, from here also infinity, but there is separation, no? In between there is a separation. So this separation you can call as B as well. If you are calling this as B, that means your A is infinity. If you are calling this as B, that means this length is infinity. And if you are calling this as A, that means this length is infinity. Are you getting this point? Either A or B will be infinity. These are two parallel plates extended till infinity. So either you put A equals to 0, A equals to infinity or B equals to infinity. Certainly here this we were taking as infinity only. When we were studying the rectangular waveguide, we were taking this length was pretty long. This is what we were taking. Here what is the scene? This length is very long, this length is very long, this length is also very long, this length is also very long. These are like two papers. This could be one paper and this could be other paper. These two papers are extended till infinity in this direction as well and in this direction as well. But the separation will be certain, like these are parallel plate waveguide. So the separation will be certain, that is written by either B or A. So if you calculate the cutoff frequency, so what is the formula of cutoff frequency? Vp by 2 under root m by A whole square plus n by B whole square. Now either you take B equals to infinity or you take A equals to infinity. What I mean to say is that you can either take B equals to infinity or you can take A equals to infinity. Formula will be same only. If I take B equals to infinity, what will be the value of FC you are getting? If B is equals to infinity, then this will be 0. So what I am getting? Vp by 2A into M. And if I take A equals to infinity, so if A is infinite, then this value will be 0. So what is the formula of FC you are getting? Vp by 2A into N. Sorry, Vp by 2B into N. So this length you will either call B or A. So if you are calling it as B, if you are calling this as B, that means A is equals to infinity. And if you are calling this as A, that means your B is tending to infinity. Cutoff frequency formula is same only, because this length B or A, one length will be mentioned. Here what is mentioned? This length is mentioned, 5 centimeter. So here if I write down the formula of cutoff frequency as Vp by 2A, if I write down the formula of cutoff frequency as Vp by 2A, that means I am considering B equals to infinity. Here what I am considering? B is tending towards infinity. So how it is dominant mode? So for dominant mode, what value you need to put? For dominant mode, here what will be your dominant mode? So dominant mode will be there for M equals to 1, right? Because if you put M equals to 1, then lowest cutoff frequency will be there. And if you put N equals to 1, then lowest cutoff frequency will be there. Are you getting this point? Again, let me pause the video. Okay. Yeah. So what I was explaining, M equals to 1 or N equals to 1. So here also, if you put N equals to 1, if you put N equals to 1, then this will be the dominant mode. Formula will be same only. Either you use Vp by 2A or Vp by 2B. The formula is coming out to be same. Right? And the mode for this is defined as, TED mode or TMD mode, where this length B or A is equals to D. Here they have written 1 0. Ideally they should have written TE1. This is the mode, TE1. That means the value of M, or you can take either N, that is 1 only. And this A is replaced by D. That means this separation is D. The distance between two plates is D. The cutoff frequency is Vp by 2B into M. Now M value 1, 2, 3, anything you can put. Are you getting this point? Right? So this is shown by this as only TED. So you do not need to study parallel plate waveguide. In parallel plate, if you have studied the rectangular waveguide, then you can derive all the formula of parallel plate waveguide. Because only the cutoff frequency will change. So how the cutoff frequency will change, that also I have told you. Because one of the value will be infinity, because it is spread till infinity. So you either take A as infinity or B as infinity. Usually we take A as the larger distance, That means I would take A as infinity, so I would use this formula. So here for dominant mode n equals to 1 I need to put, so my formula will be Vp1 by 2A. Now let's come to the second point, that is this is air, so here my Fc1 will be Vp1 by 2A, 2A is 5 centimeter. So 3 gigahertz we are getting, right? And what about your Fc1 you are getting? So now if I calculate neta 1 TE, so if I calculate neta 1 TE, what that would be 120 pi divided by under root 1 minus Fc by F whole square, 0.1 whole square minus 1 plus minus under root reciprocal into 120 into pi. So 378.89, 378.89 ohm. This is what we are getting, neta 1. Now for dielectric, that means for medium 2, if I calculate medium 2, not method 2, this is your medium 2. For medium 2 if I calculate, then I need to calculate neta 2, but for TE mode only. That would be neta 2 upon under root 1 minus Fc2 by F. Why Fc2 I am writing? Because here cutoff frequency will be different. Why it is different? Because the formula will be phase velocity of medium 2 divided by 2A. What is the phase velocity of medium 2? That is C by 2 into 2A. Why C by 2? Because here epsilon r is given as 4. So 3 into 10 to the power 8. Basically it will be half of this. It will be half of this. Whatever that I was getting here, 3 gig I was getting here. Here I was getting 3 gig. So it would be 1.5 gig. So it would be 1.5 gigahertz, right? So what will be the value you would be getting? 120 pi divided by under root 1 minus 1.5 gig divided by 30 gig whole square. So 1.5 divided by 30 minus 1 plus minus under root reciprocal into 120 into pi. So 377.46 ohm. Now if I need to calculate the mode of gamma, that would be neta 2 minus neta 1. Here I am calculating gamma only. Divided by 378.89, 377.46 plus 378.89. So what I am getting, minus 378.89 divided by bracket 377.46 plus 378.89. Neta 2 minus neta 1 upon neta 2 plus neta 1. This value is coming out to be very, very low. Am I doing any mistake? Yes. Here what will be the value of neta? What will be your neta 2? Neta 2 will be 120 pi under root mu r by epsilon r, no? What is epsilon r? 120 pi epsilon r is under root 4. So that would be 60 pi, right? This mistake I am doing. Epsilon r is 4, no? So that would be 60 pi. So here 377.46 divided by 2 will also be there. 188.73. 188.73 ohm. So 188.73 minus 378.89 divided by 188.73 plus 378.89. So you are getting 0.335. Mode of gamma, if we calculate, this is minus. So if I calculate mode of gamma, so you are getting 0.335. Now if I need to calculate VSWR, then what will be my VSWR? 1 plus 0.335 divided by 1 minus 0.335. 1 plus 0.335 divided by 1 minus 0.335. So that we are getting as 2. So this is my answer. Okay, so here important point was, this was very important. FC. What was very important? This was very important. Here cutoff frequencies will be different. Here it is 3 GHz and here it is 1.5 GHz. So this was very important point. Luckily it is not changing our answer much. Here our answer was not getting changed much because this 30 gig was very much larger than your cutoff frequency. So answer was not getting changed a lot. But what might happen is that a lot of students will forget this step, that they will put cutoff frequency both of them as same. They will say that VP by 2A, directly they will put 3 into 10 power 8 divided by 2A. So there will be the error. What will be the error? Error will be that here your VP1 will be 3 into 10 power 8, but here your phase velocity, this is my VP1. But here your phase velocity will be half of this phase velocity. So here my phase velocity is half, so my cutoff frequency is also half. So if cutoff frequency is half, then this is the neta 2 value I am getting, then gamma value I can calculate, and then from there VSWR I can calculate. So that's it about our chapter, that is rectangular waveguide. So that is completed. And one more thing, that in this video there are a lot of breaks in between, there are a lot of pauses in between because I was not feeling that well. But the chapter is done. A lot of questions has been solved, and you would be able to solve all the PYQs now. Next we need to start a circular waveguide. Okay, so let's meet in the next lecture. We will start circular waveguide.